Well, hello, my name is George, Kilo Foxtrot 5, Quebec Echo Zulu. I'm one of the founding members of the North Texas NVIS Net. Today I want to address this issue of poor ground conductivity and how it affects your signal strength. Experts referenced in our Groups I/O library all agree that you can lose as much as 50% off your signal strength when placing your portable antennas on dry or paved soil. So let's see how we can counter this effect. Now there are three basic options for correcting poor ground conductivity conditions. The first and simplest is reflector wire, which is typically mounted about 1.15 wavelengths below the radiating element on your dipole, and just a tad bit longer, about 5% longer. Simple to design, easy to calculate, very effective at increasing your signal strength and your gain. If you're moving around a lot and you haven't got as much time, you got to put your wires rig and then move. Your radials can be put in direct contact with semi-good ground, and that does help. A ground rod usually makes a little bit of a difference. Clamp it to your tripod, another little jumper to your radio, and these wires will make a difference. They're not the best, but whatever. The one this series is most about is the counterpoise. Now, I put a picture in here, a diagram, so that you can, in fact, get an idea of what we're going to do. You can have 6 radiating wires heading on out in equal distances apart. I've got a picture because I tried to take pictures of it with a camera, and those wires are so thin they don't even show up. So I've got a diagram. This is what we're shooting for. All right, let's develop a baseline. Now, this is going to be over good ground, and this is what we're going to overcome. So I've got a painter pole attached to a fence post. The buddy pole system's on top with long extended whips. They're running parallel to that fence, which is the only real obstruction out here. The buildings are all greater than 20 feet away. Good, clear view of the sky, and the soil is excellent. A loam-based topsoil, grass on it. There's moisture, so it's in real good shape. This fence running parallel to the radiating element of the buddy pole is also a good place to secure reflector wires should you need it. Now, one thing I did do with the painter pole that made it a little bit easier and to be consistent. Every one of those little dots that the pole stops at, I marked with a Sharpie on there how high that put the top of the pole. That way we can get back to the same location every time you lower it down, move the radials, move a tap, put it back up. You always get back to the same height, so you don't change that parameter as well. Okay, the one thing we got to use on these setting up your whole antenna system, especially in poor ground, is you got to get comfortable with your analyzers. You're looking for standing wave ratio, impedance, and operating at a specific frequency. Obviously, that's going to go up and down depending on what frequency you want to be on. So use your analyzer. Make notes in your field book. Date, time, place, purpose. We're here testing counterpoise systems to improve poor ground conductivity over concrete. Something so you'll know what you did it, when, time, and where you did it. Coaxial type and length, antenna height, Ballum ratios, soil type, hard rock ground, concrete, asphalt, well, turf for that matter. Do you use a radial system? And of course, any signal reports that you got. So use your analyzers, set it up, start your baseline. This looks like a nice spot right here. It's level, it's paved. There'll be no mud to deal with. Parking for everybody. But they said, don't be driving any stakes into the pavement. And with all this vegetation around here, I'm not too sure your antennas will perform that well. Our experts referenced in our group's file library refers to path pass loss as a common cause of signal loss. Vegetation is the first one on the list. Buildings too close to the antennas, no clear view of the sky, trees overhanging. This all affects your signal strength on these dipole or these NVIS antennas. So first one on the list is vegetation. If you can't clear a place, you're going to have to rig some kind of alternative, which in this case will hopefully be the counterpoise. Now we moved that same baseline antenna that we had in slide 2 there over to this concrete pad. The same height, the same tap settings, the whips are extended out fully, and the whips were retracted 4 inches to deal with the resonant frequency. So they've been retracted 4 inches, but it's exactly the same as we had it in the backyard on the green. Notice that we've starting out with a SWR 3.2, and the impedance is down to 28, and the signal reports aren't very impressive. Okay, let's build a counterpoise system right there over that concrete pad. Some tips to consider. Trip hazards. The left slide there is showing a collapsible cone, which really doesn't hold any weight. It's probably blow around the wind a little bit, but they fold up and pack away real small profile, and they're not real heavy, and you can go ahead and mark spots that you don't want people to trip over with these real easily. I would recommend considering trip hazards. By the time you get done running all these wires, you're gonna have times where you got to go from the radio back to the antenna, lower the darn thing, turn around and walk back. I guarantee you, some point in time, you will not see that radial wire, and it's real small. So trip hazards are to be considered when you're building this system. Now, the middle slide shows the antenna clamp itself, which is simply an antenna mast clamp, a U-bolt, and it has 3 radial wires connected to each one of the U-bolts. They're all snugged down and a good tight connection. And then the cones on the other end, on the right, the heavier base cones terminate the end of the radial wire. They help hold a wire up off the ground, and they also mark that location where there's another wire. Now, as you can see, now that we've got it assembled, those wires, but every one of these cones is either marking the tip of a wire or holding it up off the ground. If the public's nearby, you might consider flagging ribbon around this whole perimeter. Just make sure nobody gets in there and gets hurt. Okay, let's tune up this antenna and make some corrections for the poor ground. We're basically going to be looking at the impedance, the whip, the length of the whips based on a specific frequency, and of course tap positions. Now, the old standby, if the resonant frequency is low, shorten the whips or move tap position to reduce the number of turns on each coil. Resonance is too high, lengthen the whips and increase the number of turns on each coil. That's pretty basic stuff. Now, first thing I saw was the impedance was real low when we watched our meter. So we lowered it back down, and on this buddy pole triple ratio switching balun, I took it out of 2-to-1 and moved it to a 4-to-1. Real nice having that activity on just a simple throw of a switch. We pushed it back up, and it was doable. It was getting closer. So now we're looking at the length of the whips. Now remember, the 4 inches I retracted from our baseline antenna. Resonant frequency is too high on this system, so I pulled the 4 inches back to full extension on the deal. Now, in order to get a good, accurate measure, I would recommend using these folding wooden rulers. The idea is they'll hold up straight. You can even use them to kind of hold the ends of the whip out so they're straight, and then you're going to get a more consistent measurement on the amount of whip that you move. So I recommend making it easier on yourself and just go ahead and use that folding ruler. Okay, got the old 7300 out and put it up to a power supply in the back trunk, and we'll give it a try, see what we got. From looking at the meter, I see 50 ohms of impedance at 1.3 to 1 SWR. Sounds like a good start. Now I'm noticing that that frequency is a little bit lower than I was intending to get. I probably should have retracted those whips only 2 inches instead of the full 4 inches, but you get the point. The signal reports are clear, audio is great, signal strength are S9. It's all good, and we corrected for the bad ground conditions. Well, I have focused this event on the buddy pole antenna system. Bob, our moderator for antenna talk on the North Texas NVIS Net, first Sunday of the month, does a segment on the antenna talk. It's kind of a free-for-all, and anybody can talk about anything they want to learn about or share experiences with. First Sunday of the month, and 1400 on 7.245. Now, Bob also did an excellent position on the 40-meter delta loop, and he used a reflector with it. He got signal reports were dramatic. You can read his work in supporting XL wavelength calculators in our group's folder. Subscribe to our group site for access to a full list of the reference material. This is Kilo Foxtrot 5, Quebec Echo Zulu, and my name is George, 73.